All right, guys, welcome to Lab 5. Today this lab's going to be on minerals and pretty much how to identify them through their properties. So, that being said, so the definition of a mineral in a geological sense is it's naturally occurring, it's inorganic, so it's non-living, and it is a crystalline solid with a chemical composition. So it's different than minerals you see like in a pharmaceutical sense. So these minerals you're looking at are going to have distinct properties that kind of help you identify them. And I'll be going over those properties throughout the PowerPoint. But the main takeaway here is for minerals, at least you guys will be looking at, is naturally occurring inorganic, pretty much chemical compounds, if you will, chemical solids. So yeah, we'll get into that next. Now this PowerPoint, it's going to have 9 physical properties, but you guys are mainly going to be looking at 5. So that's why the lab section is divided up into 5 sections. And those are pretty much 5 properties you guys are going to be looking at. And so knowing how to utilize these properties, knowing what they mean and knowing pretty much how to piece them together will help you identify these minerals. And hopefully this will help you identify those properties. So the first one is luster, and luster is how a mineral reflects light. It's how light pretty much bounces off the mineral, or if light bounces off the mineral. And the 2 main ones you're going to start out looking for is metallic and non-metallic. And these ones are pretty straightforward, hopefully. Metallic is simply, does something look like metal? Does the material look like metal? And if it does, it's metallic. If it doesn't look like metal at all, or even not even a little bit, then it's non-metallic. And if you see a mineral that's non-metallic, well, you're going to decide, well, is that glassy, or is it kind of waxy, or is it dull? In a good way to kind of tie it back, if you could see something is non-metallic and it kind of does look like glass, it's not going to be perfectly transparent. But if it does reflect light in the same way glass reflects light, then it'll have a glassy luster. And so luster is good. It's pretty kind of straightforward. It's a good starting point when trying to identify these minerals. If something is metallic, that already kind of narrows your choices down, since only there's, of the minerals you guys will look at, there's not many that are metallic. And so I think these pictures do a good job. Like the one on the right would obviously be the metallic one, and the one on the left is non-metallic. And so that's kind of a good visual, even though it's kind of spiky look, whatever, you're just looking at how it reflects light on. So the one on the left is obviously non-metallic, glassy, and the one on the right would just be metallic. So luster is kind of, again, a good way to start off. Like, okay, if it's obviously non-metallic, then it can't be these minerals. And then you kind of keep going down the list of properties to help identify that mineral. All right, so next up is the property hardness. And hardness is kind of it's more of like a comparison type of property. It's pretty much a mineral's durability when compared to other materials. And so you guys are using the Mohs hardness scale. And how it works is, one is very soft, and the higher you go, the harder the material is. So this chart's kind of good. Like lead is not very hard. It's relatively soft at a scale rating of 1.5. But the further down you keep going, obviously those minerals are harder, those things. So like gold is harder than silver, silver is harder than aluminum, and so on and so forth. And the videos you guys will be looking at, the mineral will be scratched against a glass plate and a I believe a copper nail. So how you guys are going to kind of interpret that is you're going to see if the mineral can scratch the glass plate. So if the mineral does scratch the glass plate, that means the glass plate would be softer. So in the glass plate, it's just a piece of glass. But so if the mineral does scratch the glass plate, that means the glass plate is softer than that mineral, and the mineral is harder than, in this case, 5.5. So hopefully that makes sense. If the piece of glass has a Mohs hardness scale of 5.5, that means whatever can scratch that glass is harder than 5.5. It has a higher scale reading than 5.5. However, if it doesn't scratch the glass, if you see the if you see the person trying to scratch the glass with the mineral and it does not scratch, that means the mineral is softer than 5.5, which means its Mohs hardness scale is going to be smaller than 5.5. And another comparison you guys will see is with the fingernail. And you'll have a chart too on that question in your lab assignment. But if a fingernail is able to scratch the mineral, that means the mineral is softer than your fingernail. And if the fingernail can't scratch the material, that means the material is stronger than the fingernail. So hopefully that makes sense. Again, so I can do a visual for you if you guys help, if that'll help. So say, yeah, we'll just do this right here. Say you have this red. Say you have this red mineral here. Make it a nice big square. And say you take your fingernail. Or no, let's use glass plate. Let's say you take it, you rub it up against glass plate here, and it does not scratch that glass plate. So you rub it against glass plate and you don't see any line, you don't see any scratches on that glass plate. That means the glass plate was stronger and that mineral its hardness is less than 5.5. And then from that, you could scratch it with your fingernail, and if your fingernail can't scratch it, then you know the range would be between 5.5 and your fingernail, so that'd be like 2.5. Again, there's a chart on that question to show you, but that's just to give you an idea of kind of relative hardness, again, to help you identify the mineral. All right, so next up is going to be this term called crystal faces. So what crystal faces are is, as it says here, it's pretty much a set of defined faces, and pretty much it's a geometric relationship to each of those faces. And this isn't really a great example, but here we go. So there's two different types. For example, so a cube is a good example of a kind of crystal face that's pretty common, pretty easy to understand. So you guys are pretty much just going to identify the types of crystal form. And so that's going to be right here at the bottom. So it's just pretty much knowing what to look for when you see a crystal form. Not every mineral is going to have one, but you're going to have cubes. You're going to have, like an octahedron and a dodecahedron. This next slide is also a few more. So you don't need to necessarily memorize the definitions of these forms. It's a lot to memorize, so you don't need to memorize that. It's just pretty much looking at these shapes, seeing if a mineral kind of has these general shapes. Not every mineral will, but the ones you look at may have, so may have a dipyramid, or maybe a pyramid with a prism, or a tetragonal prism. So you guys are just pretty much looking for these kind of general geometric shapes of the minerals, if that makes sense. And you can obviously reference this PowerPoint too to help you. So next is going to be this term called mineral cleavage. Now, mineral cleavage is pretty much how the mineral breaks. Now, not every mineral is going to have these planes of cleavage. I'll get into that, but I'll kind of explain some more. So, what mineral cleavage is, it's pretty much these planes of weakness, pretty much between the atoms, based on how the atoms are bonded, and they're how these minerals break. Let me give you an example here. So here's a good example. So if you take a cubic mineral, that means it has three planes of cleavage and 6 faces. So I'm going to draw that out to kind of give you guys a visual. So how these planes of cleavage are identified is, it's almost called like this crab pinch method. So if you're pretty much looking at the mineral, if you had it in your hand, you would look down and see, here's one face, and here's another face. Right now, that's pretty bad. Another face here, kind of at the bottom. So right there, that's one plane. That's one cleavage plane. And so now to find the third cleavage, or the second cleavage plane, I'll use blue here, that's going to be, take it from the side here. All right, so that's, again, so now we've identified 1, 2 in the red, that's 2 different faces, and then 3, and then 4, that's 4 different faces, 2 cleavage planes, and now we'll identify the last one is here. Here's one right here. It's 5, and then obviously the one kind of at the back here. So that plane in the back. So now you can kind of see visually the planes of cleavage. So they're all in different colors. So the red, the blue, and the black, those are 3 different cleavages or cleavage planes on where this mineral would break. I know it's kind of confusing at first, but yeah, that's how you kind of identify cleavage planes. If a mineral has a pretty a relatively specific shape, or pretty much specific way it breaks, that's how you identify these cleavage planes. And a more simpler one would be one here in this bottom right corner. Is this, it's pretty much got 2 faces but 1 cleavage plane. So you pretty much just got a top and a bottom. And that's pretty much it. That one just only has 2 faces, 1 plane of cleavage that it breaks along. And you'll look at a mineral kind of like that. For example, muscovite has just 1 plane of cleavage. It kind of breaks it's almost like paper or plastic, but it's only got 1 cleavage plane. Or as opposed to, say, this cube, it's got 3 cleavage planes that are created by 6 faces. And then it can get kind of more complicated from there. If you look at this octahedral one, you could have 8 faces, which means you would have 4 planes of cleavage, and so on with the dodecahedral. You won't necessarily need to count all of the faces on these minerals, but this is kind of how you identify cleavage for the minerals that do have cleavage. Hopefully that makes sense there. And some more examples of cleavage. See here. There are some minerals that don't have cleavage. Quartz. So quartz, it does kind of have these unique shapes about it, but it doesn't break kind of along in those shapes. Whereas with like this example here, actually there's a better example on the next page, where example biotite here, it's much more, it's papery, and it's got a much more kind of distinct shape and a distinct way of how it breaks. Again, this breaks along that one plane of cleavage, kind of shown here with the basal breakage. So when you're trying to see if a mineral has cleavage, just kind of look for crystal faces and pretty much possible planes of cleavage when you're looking at them in the video. I know it's harder to do through video, but you're pretty much looking for planes. Whereas if you see this picture, of course, there's no distinct cleavage plane really for this mineral when compared to, say, biotite or muscovite. So that brings us to the next part. So this is something called fracture. Now, if a mineral doesn't have cleavage, then it has fracture. So let me see if there's a good. No. So like with this picture here, there's no really distinct planes of weakness. You can't really count crystal faces on it, as opposed to a cube or, a square. So when a mineral doesn't have cleavage, when it doesn't have those cleavage planes, it has something called fracture. And it's just, again, it's the way the mineral breaks when it doesn't have planes of weaknesses. And another kind of general rule here is it's usually irregular type of fracture. So there's 2 types of fractures when you identify. So once you identify if a mineral has either cleavage or fracture, you're like, okay, well, it doesn't have cleavage, so it has fracture. When you get down to fracture, you guys are only going to be looking at 2 types of fracture. And so there's irregular, which would be this one. And then there's something called conchoidal fracture. And this is something you kind of see more in like obsidian or in glass. You can see this in glass. And it's when it's kind of the mineral, when it breaks, it kind of has curved surfaces when it breaks, and so you can kind of see it on the mineral. So just kind of back up a little bit. If a mineral doesn't have cleavage, it has fracture. If a mineral doesn't have fracture, it has cleavage. So cleavage is much more distinct and is pretty much more uniform throughout the mineral, as opposed to fracture. Fracture is much more irregular and does not have any distinct planes of weakness. And for fracture, it can either be irregular or conchoidal, where it has these curved surfaces on the mineral. Hopefully that makes sense. And the next property is streak. So what streak is when a mineral is pretty much pulverized like powder, or in this case, it'll be scratched against a white scratch plate, and it'll leave a streak behind of that mineral in powder form. So like in this picture here, this kind of blackish looking mineral was scratched against the scratch plate, and it left behind a black scratch almost, or a dark gray color. And that's its streak. Its streak is the color it leaves on that a white scratch plate. And similar on the right, you could tell it's kind of, well, it looks like a dark red, but when scratched on the scratch plate, it leaves a kind of brownish streak, a brownish reddish streak. And so streak is good for identifying minerals that do kind of look similar. And when scratched on the plate, if they leave behind a different color streak, then that can help you identify, okay, well, that mineral's that mineral's that. So it's just another kind of way to identify a mineral. And this is another good point here, is the color of the streak the mineral leaves behind can be both distinctive of that mineral, and it can be different than the color of the mineral itself. So like these two examples up here, we have cinnabar to the left, and it's definitely more of a dark gray black colored mineral, but its streak leaves behind is brown. It's almost like a reddish brown. And same with here, pyrite to the right here, it looks like fool's gold. It's kind of gold colored, but it scratches, it looks like dark gray, almost black. And so that's why streak can be very distinct amongst the different minerals. So it can be pretty specific to a certain mineral once you got it narrowed down, once you got the luster down, and then the hardness, and then this shape, and then the fracture or cleavage. Once you have all these things, and the streak can kind of be your final tell of what the mineral is. So that's pretty much it. The last part is color. Color is a very superficial property. You don't want to identify a mineral solely off color. However, it can help you, but it's not always the best property to use, just because some minerals can have, their color can vary widely. And it can be kind of ambiguous, as the slide said, but it also can be very distinctive. For example, like olivine has a very distinct green color. It's like a dark, almost olive green. So color is just, it's kind of, you don't really have a section on color. It's just, it can be a way of identifying mineral. And now the last few slides, I won't go over them because unfortunately you guys aren't really going to look at them as much. It'd be a lot better, a lot more useful if we had in-person classes, but I'll leave them up there just because those are ways to identify minerals. You just guys won't be using those properties for your assignment. So pretty much up to slide 17 is what you guys are going to use to help you. So I hope this helped. I hope this helps a little bit. Again, you can message me if you have any questions. You can keep this PowerPoint up while you're going through the lab assignment if you want, to kind of help you reference it. But I'll post the PowerPoint on Canvas along with this lecture. And with that, again, if you have any questions, please reach out. I'll get back to you as soon as I can, and hopefully I can help you out. And if you have any problems with the videos or any of the modules on Canvas, just let me know. I'll get that fixed for you. Otherwise, good luck, and yeah, till next time.